All right, so this is 2.5. Again, we're getting into the proofs, using a lot of our geometry terms now in this section. So for this next one, we had to name the properties that the statements illustrated. So again, these are pretty much the same properties that we talked about before. Properties of equality that are now properties of congruence. But notice they did do two of these as congruence. They did one as equals. So copy, let's see, over here. On this one, we have if angle DEF is congruent to angle JKL, and angle JKL is congruent to angle DEF. Well, we took the same two angles and we just flipped it around. That is symmetric property of congruence. Now, for the next one, we have the exact same angle equal to itself. So that's the one that I mentioned on the last video. It's going to become very important later in the year. Reflexive property, again, with an X, reflexive. All right. Then number 3, the third one down there, 34. This is the only one that is not going to be one of our properties of congruency because we're using equal signs. So this is a property of equality. Now, just like on the last one, this can actually be one of two things. We could either have transitive property or substitution property. We're replacing the entire thing. So again, it could be either. Either one is acceptable there. All right. So that's all we were doing for those first 3 on this one, or 32 through 34. 35, we're actually writing a proof. So let's go down to those. And that, let's see. Actually, let me see if I can't fit 35 and 36. Yeah. All right. So now we need to go through and do this 2-column proof. Again, I'm going to try to abbreviate as much as possible. So it wants a 2-column proof for the reflexive property of angle congruence. So again, that's saying that an angle is congruent to itself. So all we have to be given is one angle. All right. So we can start it off. And I'll do the same proof that the book did. So let's say we're given an angle to start with. Well, what angle is that? So we need to write out what we're trying to prove with what we're given. So given, prove, and say we're just given angle A. Great. What are we trying to prove? We're trying to prove that angle A is congruent to itself. Angle A is congruent to angle A. Now, we already did this proof earlier in the notes. So again, if you flip back, you would see this one. It's not exactly the same, but it's very close. So we started off with, we have an angle, angle A given. So angle with vertex A. All right, so that was given to us. We have an angle with a vertex that's labeled A. So then what's the first thing that we can really say about this angle? Well, if we know that we have angle A, well, you can say the measure of angle A is equal to the measure of angle A. How can we say that? Well, because of a reflexive property. The answer in the back of the book on this one threw in an extra step, which we didn't have the last time. But again, reflexive, and this is property of equality. So we have an angle. We know that we can say that its measure is equal to itself through reflexive property of equality. And if it is equal to itself, then it is congruent as well. So angle A is congruent to angle A. Why? That's the definition of congruent angles. Definition of congruent angles. All right. On 36. a ramp at a skate park is constructed. All right, so they have the ramp in the picture. Angle BAD, you can go ahead and label this BAD, is congruent to angle CDA as pictured. Prove. So now what I did in blue, that's what they're giving us. What they want us to prove is that EAB is congruent to FDC. All right. So this one's not too bad. I think we can keep it pretty short. I feel like the book did a lot of extra work when you look in the back of the book for this one. I'm not really sure why. I think I can cut out several of the steps that they did. Maybe they just assumed we didn't know some of the postulates and theorems so far. I'm not sure. But we have our statements. We have our reasons. What do we know? Well, we know that angle BAD is congruent to angle CDA. How do we know that? It was given. Then, after we know that those two are congruent, well, we know that we are dealing with some angles. If they're congruent, they are equal in measure. So I'm going to say that the measures are equal. So measure of angle BAD is equal to the measure of angle CDA. How do we know that? That's our definition of congruent angles. All right. Next. We can't really do anything else with what's given to us there, but if we look at the diagram, these angles that we're going to be using, along with the angles that were given to us as congruent, these angles form a linear pair. So we have two linear pairs there. We have now we can say that they're a linear pair and use the definition of a linear pair, but we've also already done our linear pair postulate, which goes straight from the definition all the way to the fact that they equal to 180. So let's go ahead and skip that step of doing the definition by using our postulate. The measure of angle EBA. Sorry, no, that was right. EAB plus the measure of angle BAD. I'll make sure I keep using them in the same order that they appeared originally to make this easier. Equals 180 degrees. All right. Then, same thing still, but for the other set, measure of angle FDC plus the measure of angle CDA equals 180. How do we know that? That is linear pair postulate. That's for both of those. Linear pair postulate. Probably should have drawn some lines there. What's my lines? My given statement. I have that statement next. All that went together. So now, what can I do next? Well, since they're both set equal to 180, I can equal them to each other. So measure of angle EAB plus measure of angle BAD is equal to the measure of angle FDC plus the measure of angle CDA. How do I do that? That's transitive property of equality. And then finally, there's really only one more step that I need, which I'm running out of space here. Let's see if I can move this. here. Yeah, let's set it right here so that I can get that last line in there. So the last line. Actually, no, 2 lines. There's still 2 lines. We know that these angles were equal back up here from line 2. So it doesn't matter which one I switch out, but I need to switch one of those out. So let's just replace BA. Let's see, BAD and CDA. BAD and CDA. Okay, I'm going to replace the CDA at the end with BAD. So we have measure of angle EAB plus measure of angle BAD equals the measure of angle F, that's with B, no, FDC, plus the measure angle. Now, this is the one I'm substituting, BAD. And you heard me, substitution, property of equality. And I got one more line, it's the last line, and I'm running out of room here. But it's going to be the fact that, let's try to move this again. Uh-oh, I dragged some other stuff with me. I don't want this stuff. Whoa. What happened? There we go. Okay. Last line is what we're trying to prove. Measure of angle EAB is equal to, I still have it equals. So there's one more step. How did I say that? Well, we subtracted. And finally, we can say that the congruent angle EAB is congruent to angle FDC. Why? Definition of congruent angles. Whew, okay. I don't know if that was any shorter than the way they did it in the book. Let me see. I remember thinking that they did it a funny way. I mean, they did it very similar. They just went in a different order. So again, proofs can be done in different orders a lot of times, but that was it for 2.5. Again, the next one will be 2.6.